Good morning, everyone. This is Ms. Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Rao Deshpande Institute of Technology, Haliyad. So in the previous class, we were discussing about what we mean by calculus of variation and what are functionals, whatever we have discussed in the previous class. That's first we have discussed what do you mean by functionals. We will start from the definition of functions. What do you mean by functions? We have learned about functions in our previous class. It's nothing but it is a mapping from the set of real numbers to the set of real numbers, or it may be anything. It is a mapping from the domain to the codomain. It is from the domain to the codomain where each member is a unique number in the codomain. Each number in the domain is assigned to a unique member of the codomain. Then we say that there exists a function. So if you can say that if you take the function, for example, f of x is equal to x, that means if you take the numbers in the domain as the numbers say 1, 2, 3, 4, you will have the numbers in the codomain, the multiples of 2. So it will be 2, 4, 6, 8. So there is a mapping. 1 is mapped to 2, 2 is mapped to 4, 3 is mapped to 6, 4 is mapped to 8. So each member of the domain is mapped to a unique element of the codomain. Suppose if there is an element over here. Suppose if you have an element say D which does not have any term over here to get mapped, then it does not form a function. So there should not be any single element without mapping. All the elements of the domain must have an image in the codomain. Then only we can say that there exists a function. Okay, this is regarding functions. Similar concept you apply to functionals. That means here the domain contains all the set of functions. The domain contains a set of functions which are mapped to the real number. That means all the functions which are there in the codomain, the set, the codomain set and the domain set. So you can have some elements left out over here. It doesn't matter. You can have some elements which are left out in codomain. But to form a function, you should have the domain where each and every element has the image in codomain. That means here in the case of functionals, you have the domain as the set of functions. So all the types of function which form functions. So those are the elements which are present in domain. So suppose if all the elements of the domain where the domain contains a set of functions is assigned to a real number, then we say that there exists a functional. So this is the difference between function and functional. Then we use to represent functionals in terms of the definite integrals. It is given by I is equal to integral x1 to x2 f of x comma y dash into dx. Then we have derived a necessary condition for the functional to achieve an extremum. We determine a function. Here in this case what we do, we determine a function say y equal to y of x which satisfies the conditions y of x1 equal to y1, y of x2 equal to y2 such that our given function f of x y comma y dash, that is I of y, attains extremum. It attains extremum. So you making use of calculus of variation, we find the necessary condition for the functional to attain extremum. Necessary condition is given by Euler's equation. The necessary condition is given by Euler's equation, and we have derived this Euler's equation in the previous class. So how is it defined? How Euler's equation is defined? It gives us the necessary condition for the functional to achieve an extremum. Anybody remember how it is obtain necessary condition for the integral, say I is equal to integral x1 to x2 f of x comma y dash into dx, where y of x1 equal to y1 and y of x2 equal to y2. To be an extremum is that dou f by dou y minus d by dx of dou f by dou y dash, that is equal to 0. So this is the necessary condition for the functional to achieve an extremum, that it should satisfy the condition, and we are finding the function y equal to y of x. We are finding the functional so that we get a necessary condition for the functional to achieve an extremum, and this is that condition which needs to be satisfied. So we have derived this Euler's equation in the previous class, which is a very important concept. Everybody please go through that. And we have discussed 2 questions based on that as well. Let's discuss few more examples in today's class. Okay. So let's discuss. Find the extremal of the functional. Find the extremal of the functional integral a to b x square y dash square plus 2y square plus 2xy dx. Integral a to b x square y dash square plus 2y square plus 2xy into dx. So we need to find the extremal of this functional. That means we need to find the function y equal to y of x. For that what we do, we take the function, the given function f of x comma y dash, that is x square y dash square plus 2y square plus 2xy. This is the function which is given to us. Next we apply Euler's. What is Euler's? It is dou f by dou y minus d by dx of dou f by dou y dash. Easy to remember. Dou f by dou y minus d by dx of dou f by dou y dash. Now how this equation gets transformed to? Check this. How this equation gets transformed to when you substitute in Euler's equation. What do you get when you substitute in Euler's equation? Differentiation of f with respect to y. What is it? See, this term will be 0, and see, you have this x square y dash square plus 2y square plus 2xy. So partially differentiate this f, this is f, with respect to y. So what do we get when we differentiate? This term will be 0. So here you will have 2 into y square, differentiation y, so 2 into 2 it will be 4y, plus differentiation of 2xy with respect to y is 2x. So dou f by dou y is 4y plus 2x. Then minus d by dx of dou f by dou y dash. Now given the equation here, you need to differentiate that one with respect to what? With respect to y dash. Now differentiate that with respect to y dash. Dou f by dou y dash. First term, x square, y dash square. Differentiation of y dash square is 2 into y dash. So what do we have over here? 2x square y dash. And remaining term will be 0, as they do not have any y dash term. So they will be considered constant. Partial differentiation concept we are applying over here. So now what is dou f by dou y dash? We get d by dx of 2x square y dash, that is equal to 0. So this is what we get after we substitute in Euler's equation. Is it okay, everyone?
Yes, ma'am.
Is it okay? Okay. Now what shall we do? How to solve this one? First differentiate this. What do we get when we differentiate this? This is 4y plus 2x. This is equal to 4x. Now you have to differentiate. Differentiating, what do we get? Minus d by dx of 2x square y dash. So here we have to apply product rule, because y dash is nothing but what? It is dy by dx, correct? So we have to differentiate with respect to x. That means we have to apply the product rule over here. So it will be first term into differentiation of second. 2 into x square into differentiation of y dash will be y double dash plus. Now 2 into y double dash into differentiation of x square will be 2x. That is equal to 0. So what do we get now when we simplify this entire equation? We get 4y plus 2x minus 2x square y double dash minus 4x y double dash equal to 0. So we shall divide the entire equation by 2, then we rearrange the terms, either 2 or minus 2. We divide by minus 2 and rearrange it. When we divide by minus 2 here, what happens? We will have x square y double dash. Here when I divide by minus 2, it will be plus 2x y double dash, and here when I divide by minus 2, it will be minus 2y minus x 0. So then this can also be rewritten as, that is, x square y double dash plus 2x y dash minus 2y equal to x. This is the equation, final equation we get. Now what we do is, in order to solve this equation, we have discussed how to solve higher order differential equation in second semester. I hope you all remember. In order to solve the second order differential equation, we sometimes make the substitution. Say, put a t equal to log x. If I put t equal to log x, what will be x? From this, x will be e power t. If I put t equal to log x, x will be e power t. Apply exponential on both sides. E power t equal to e power log x, which is x. Now from this equation, remember this is a second order differential equation where we do not have that, not a homogeneous differential equation. This is not a homogeneous differential equation. This is a non-homogeneous differential equation. If it was a homogeneous differential equation, we would have equal to 0 over here. But we do not have it. So that's why we make the substitution. Let's put t equal to log x, where x is equal to e power t. Then what will be x into y dash? Go through this in the second semester. We have learned this substitution. All those substitution, what we have to make? We have to put x y dash is equal to d into y, x square y double dash as d into d minus 1 into y, where capital D is nothing but d by. Solve this differential equation by making use of this substitution. See, x into dy, x y dash will be taken as dy, x square into y double dash is taken as d into d minus 1 into y. Now make the substitution in the given equation star. When we make the substitution, x square y double dash is replaced by d into d minus 1 into y. Then plus 2xy dash plus 2 into xy dash is given by dy. Then what else we have? Minus 2y, correct? Minus 2y. Am I correct? Minus 2y, that is equal to x. What is x? E power t. So when we make the substitution, you have to change this. This will be e power t. So what we will have when we take y term outside? We will have a term d square minus t plus 2d. So it will become d square plus d. Then here you will have minus 2 into y. When you simplify this, you will get this term. So d square minus t minus t plus 2d. So it will be d. Then we have minus 2 into y, that is equal to e power t. So this is the equation what we are going to get. We have converted this given equation star. We have converted when we have the polynomial term inside. Go through that in the second semester. We have discussed about it. So that time we will make the substitution t equal to log x. So x will be e power t. x y dash can be taken as d into y, x square y double dash is taken as d into d minus 1 into y. Then I make the substitution over here, we get our equation which we need to simplify. How do we solve the second order differential equation? Second order differential equation, first we need to find the solution of the homogeneous part, then we need to find the solution of the non-homogeneous part. So our homogeneous part is this one, d square plus d minus 2. So suppose if we have the equation d square plus d minus 2 into y equal to 0. This is the homogeneous part of that equation. So how do we solve this? We have to find the auxiliary equation. What is the auxiliary equation? We have to replace d by m. So we will have the auxiliary equation m square plus m minus 2 equal to 0. Or else you can simplify it as, how you can write it as m minus 1 into m plus 2 equal to 0, where what are the values of m? 1 and minus 2. Am I correct? Is it?
Yes, ma'am.
Yes, ma'am.
Okay, so we have got m equal to 1 and minus 2. How do you write the complementary solution of this? So you have two distinct real roots. When you have two distinct real roots, the complementary function is given by c1 into power t. See here the variable is in terms of t. This right hand side variable is in terms of t, that's why you have to write it as e power t. Then second root is minus 2t, so it will be c2 into e power minus 2t. This is how you write the complementary function. So this is the complementary function, write it in terms of x now. So what will be c1 into, we know that e power t taken as log x. See over here, t is taken as log x. So what will be e power t? If t is log x, what will be e power t? Is it so difficult? E power t, when t equal to log x, what we will get? E power log x. What is e power log x?
X, ma'am.
What is x? E power log x is x. So we will get x plus c2 into e power minus 2t will be what? E power minus 2 log x will be what? You can write it as e power log x power minus 2. E power log x is x. So e power log x power minus 2 will be x power minus 2. So it will be c2 divided by x square. Is it clear? Anybody has any doubt in this? Please ask me. Anybody has any doubt in this?
No, ma'am.
No? Please reply.
No, ma'am.
No, ma'am.
Can you all hear me?
Yes, ma'am.
Yes, ma'am.
Yes or no?
Yes, ma'am.
Okay. Okay. Let's continue now. So we have found the complementary function. Let's find the particular integral. So what is yp? How do we find yp? Remember, yp is nothing but whatever term we have, f of d. This is the f of the term which is on the right hand side. That is e power t divided by f of d we have to do. This is of the form f of d into to say some function of t. So what we have to do, this term, the term divided by f of t. So we have over here, the term is e power t divided by f of d is d square plus d minus 2. So now what happens when you have e power x divided by f of d? What we used to do, anybody remember? Suppose if you have e power ax divided by f of d, that time what we used to do? We used to replace the terms which are there e by a. Try to recollect all these things when we have to find the second order differential equation solution. Suppose if you have a term e power ax by f of d, you should replace d by a. You should replace d by a. So now what happens? Here in place of a we have 1. denominator becomes equal to 0. Remember, are you trying to recollect all these things? Yes?
Yes, ma'am.
Okay. When the denominator becomes equal to 0, what we used to do? We used to multiply by t, correct? We used to multiply by the variable t into e power t divided by differentiate the denominator. So what happens when we differentiate the denominator? It will be 2d plus 1. Am I correct?
Yes.
Yes?
Yes, ma'am.
Suppose if the denominator becomes equal to 0, we used to multiply by t, then e power t divided by differentiation of the denominator. It is 2d plus 1. Now again repeat the concept. Replace t by 1. When we replace t by 1, we get 2 plus 1, that is 3. So now replace the variable t by x. X is what? Log x. E power t will be, what will be e power t? It is x. E power t will be x divided by 3. So what is the particular integral yp equal to? It is x log x divided by 3. So what is our function y equal to? Complementary function plus particular integral. What is the complementary function? We have found here yc, that is c1x plus c2 divided by x square. Then the particular integral, it is x log x divided by 3. Any doubt in this problem? Please ask. This is somewhere related to the previous semester we have discussed. Anybody has any doubt? Please ask me if you have any doubt. Anybody has any doubt?
No, ma'am.
No, ma'am.
Okay. Let's discuss the next question. Find the curve on which the functional, we need to find the curve on which the functional 0 to 1 y dash square plus 12xy into dx with y of 0 equal to 0 and y of 1 equal to 1 can be determined. We need to find the curve on which this functional with the initial values can be determined. So what is our functional? I is given integral 0 to 1 y dash square plus 12xy dx. So let's take the function f of x comma y dash as y dash square plus 12xy. So this is our functional. Apply Euler's equation. What is Euler's equation? Dou f by dou y minus d by dx of dou f by dou y dash equal to 0. This is Euler's equation. Let's substitute in this. Here we have an equation f. So what is dou f by dou y? This will be 0 and this will be 12x. What will be dou f by dou y dash? So this term will be 0 as it does not contain y dash term. So it will be 2y dash. Correct? Now let's substitute in the equation, Euler's equation. Dou f by dou y is 12x minus d by dx of dou f by dou y dash. It is 2y dash equal to 0. Now let's differentiate. What do we get? 12x minus differentiation of 2y dash will be 2y double dash. That is equal to 0. Or this, when what do we get? What is the value of y double dash? When we divide throughout by 2 and rearrange the term, we get y double dash is equal to 6x. Now what we do is we need, see from this we need to find y of x. Our ultimate goal is to find y of x. So y is directly given over here. Unlike in the previous case, we had to use the concept where the equation was in terms of second order differential equation, where we have to find the solution of the differential equation to find the value of y. But here it is not that case. Here it is very easy. The y double dash is given. What is y double dash? Y double dash is nothing but d square y by dx square equal to 6x. In order to find the value of y, we need to integrate twice. Done. So integrate, what do we get? On integrating, first time you integrate, what do we get on integrating? On both sides, we get dy by dx, that is equal to, integrate with respect to x. What do we get? Integration of x, it will be x square by 2 plus the constant, we take it as c1. That is, what will be dy by dx? Dy by dx is 3x square plus c1. Now integrate again. We need y. Integrating again. What do we get integrating again? We get y is equal to integration of 3x square plus c1. c1 a constant. Correct? So integration of this term with respect to x plus the constant c2. Am I correct, everyone? Anybody has any doubt in this?
No, ma'am.
Okay, now integrate this term. What do we get on integrating? Here we get the value of y as integration of the it is a constant term, so that will be, it will be c1 plus c1x plus c2. So this is that. So what is our ultimate final answer? X cube plus c1x plus c2. So this is our function y at which are given extremal, attains extremum. But now check that conditions are given. With the conditions, we need to find the curve on which the functional integral 0 to 1 y dash square plus 12xy dx with y of 0 equal to 0 and y of 1 equal to 1 can be determined with these two initial conditions. So let's use conditions. The conditions. What are the conditions? Using the condition y of 0 equal to 0. Y of 0 equal to 0 and y of 1 equal to 1. That means y value is 0 at x equal to 0. Y value is 1 at x equal to 1. So what happens when we substitute all these things in the given equation y? When y equal to 0, you put x equal to 0. So here you have y equal to x cube plus c1x plus c2. Now you put y equal to y of 0 equal to 0. That means when y is 0, x is also 0. 0 equals 0 plus c1 into 0 plus c2. So what do we get from this? c2 equal to 0. Now what happens when you put y of 1 equal to 1? 1 equals 1 plus c1. Then what do we have over here? c1, x is 1 plus c2. And we know c2 is 0. 1 equal to 1 plus c1. From this what do we get? c1 is also equal to 0. Am I correct? 1 minus 1 equal to c1. So c1 is also equal to 0. So when we put these initial conditions, we get the values of these constants as 0. So now let's substitute all the values of c1 and c2 in the given equation. That times what happens? Only x cube remains because c1 is also 0, c2 is also 0. So y equal to x cube is the required curve. Anybody, any doubt in this?
No, ma'am.
Anybody has any doubt? Okay. Practice this question after my class. Let's discuss next question. Solve the solve the variational problem. So here it is, next question we will discuss. Solve the variational problem where delta stands for the variation. It is given by delta 0 to 1 x plus y dash square into dx equal to 0. Solve this variational problem under the conditions. Conditions are given y of 0 equal to 1 and y of 1 equal to 2. These are the conditions which are given and we need to solve this variational problem. So let's consider this as let I is equal to integral 0 to 1 x plus y dash square into dx. I take this as our integral, this entire term. Now what happens? Here we have delta, correct? This delta I will be, this entire term is what? Delta I. If I consider this as delta, this delta with the integral becomes delta I. and delta equal to 0 is similar to our Euler's equation which we have derived in the previous class. We have derived this Euler's equation where we have proved that delta H is equal to 0. That means the entire delta I equal to 0. We have used only this term to get the Euler's equation. We have used only I to get the Euler's equation. So here we have delta I equal to 0. So delta I equal to 0, it is nothing but it is equivalent to the Euler's equation, where what is the Euler's equation? Dou f by dou y minus d by dx of dou f by dou y dash, that is equal to 0. So let's consider a function. Let f of x comma y dash. What is f of x comma y dash? It is x plus y dash square. So this is f of x comma y dash. Now when we substitute all these values in Euler's equation, first what is dou f by dou y? What is dou f by dou y? It is 1. Am I correct? What is dou f by dou y? This will be 0. Differentiation of y will be 1 and this will be 0. So dou f by dou y is 1. What is dou f by dou y dash? This is 0, this is 0. It will be 2y dash. Now let's substitute this in the Euler's equation. Dou f by dou y is 1 minus d by dx of dou f by dou y dash. Dou f by dou y dash is 2y dash, that is equal to 0. Now differentiated, what do we get when we differentiated? D by dx of 2y dash. What will be d by dx of 2y dash? Differentiation of y dash, it will be y double dash. So 2 into y double dash equal to 0, or what will be y double dash? What will be y double dash?
1 by 2.
What is 1 by 2? So we have y double dash. So y double dash is what? D y by dx square, that is equal to 1 by 2. We need to find y. So what we do? We integrate it twice. So we have d square y by dx square, that is equal to half. Integrating, what do we get on integrating? dy by dx, that is equal to integration of half. This integration of half.
X by 2.
Tell me. X by 2 plus constant c1. Now integrate again. Integrating again. What do we get? Integrating again, we get y. And integration of x by 2 plus c1 and the constant c2. So what is integration of x by 2 now? Integration of x is x square by 2. So we get x square by 2 into 2, it will become 4. Plus integration of c1 with respect to x is c1x plus c2. So this is our y. Okay, so we got a curve y. Now we have to use the conditions. What are the conditions? Here it is given. Y of 0 equal to 1 and y of 1 equal to 2. So first one, y of 0 equal to 1. So when y is 1 at x equal to 1, what will be the value of y? So what do we get over here? So y will be 1 equal to x is 0. So the x 0 by 4 will be 0 plus c1 into 0, correct? That is plus c2. So what will be the value of c2? It is 1. Correct? When you put y of 0 equal to 1, the value of y is 1 and x equal to 0. X is 0, so this term will be 0, this term will be 0, C2 is equal to 1. Next, second condition. What is the second condition? Y of 1 equal to 2. Second condition is y of 1 equal to 2. So y of 1 equal to 2, that means y value is 2 when x equal to 1. So x is 1 by 4 plus c1 into x. So C1 plus C2 value we have found out, substitute that, it is 1. So rearrange this term and find the value of 1. What do we get? 1 as C1 as, it will be, take the other terms, 2 minus 1 by 4 minus 1. So what is it? Is it 3 by 4?
Yes, ma'am.
Yes? Yes, okay. Now let's substitute the value of C1 and C2 in this one. What do we get from star? When we substitute the value of C1 and C2, we get y equal to x square by 4. C1 value is 3 by 4. So plus 3x by 4. C2 value is 1. So this is our function. You can also rearrange and write it as 4y equal to x square plus 3x plus 4. So this is our curve. You can stop it here also, doesn't matter. Anybody has any doubt in this? Please ask if you have any doubt in this.
No, ma'am.
Sure.
Yes, ma'am.
Yes? Shall we continue?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay, let's discuss next question. Solve the variational problem. Solve the variational problem. Delta integral 0 to pi by 2 y square minus y dash square into dx equal to 0 with the conditions y of 0 equal to 0 and y of pi by 2 equal to 2. Y of pi by 2 equal to 2. So now see, this is of the form delta I equal to 0 where this is I, and from I let's write what is f of x comma y dash. It is y square minus y dash square. Now let's substitute this in the Euler's equation. What is the Euler's equation? Dou f by dou y minus d by dx of dou f dou f by dou y dash equal to 0. So let's find what is dou f by dou y. What is dou f by dou y? It is, what is dou f by dou y? It is 2y. Am I correct? Dou f by dou y is 2y. What will be dou f by dou y dash? It is minus 2y dash. Let's substitute in Euler's equation. We get 2y minus d by dx of minus 2y dash, that is equal to 0. Or this can be simplified as 2y minus of minus will become plus. Differentiation of 2y dash will be 2y double dash, that is equal to 0. So what we have when we divide by 2, what do we get when we divide by 2? Y dash plus y equal to 0. Correct? Yes?
Yes, ma'am.
Okay. Now how to solve this? We have obtained a higher order differential equation, higher order homogeneous differential equation. How to solve this one? Higher order differential equation. How to solve this one? Tell me. Higher order differential equation. How to solve this one? Anybody remember how to solve this one? Nobody remembers? No? Nobody remember? We have to make the substitution. Y double dash is equal to d into d minus 1. What happens then? D into d minus 1. Here we have plus 1 into y. That is equal to 0. So from this what do we get? D square minus d plus 1 into y equal to 0. What are the roots of d square minus d plus 1? What are its roots? What are the roots of d square minus d plus 1? If you consider the homogeneous part, m square minus m plus 1 equal to 0. How do you find the roots of this? What is m equal to?
-1 plus 2.
Minus b. 1 plus or minus square root of b square minus 4 into 1 into what? 1 divided by 2. What it is? 1 plus or minus. Am I correct?
Yes,
Yes
ma'am.
or no? How do
Yes,
you
ma'am.
find the
Yes,
solution
ma'am.
of this? So what are its roots? What are the roots? What are the roots? You just tell me the roots of this.
Ma'am, slide is not visible, ma'am.
To everyone, nobody can.
No, ma'am, it is
Or
visible.
only few.
Visible, ma'am.
Okay, okay, okay. Check how do you do it. I want the solution answer from you all for this. How to do it. No? Anybody? Anybody? Please go through the second semester book and find the solution of this. So this is a homework for you all. Please note down this. This is a homework. You need to solve this. First here what you need to do is you need to find the homogeneous equation we have got. So find the solution of the homogeneous equation. You will get an equation. From that equation you substitute these two values. So you will find the value, the curve y. You will get the curve y for this. Just go through the previous semester and find how to find the solution of this, how to find the solution of the homogeneous part of this. Is it okay? Note down
Okay,
this,
ma'am.
everybody. Okay, let's discuss the next question. Show that the functional integral x1 to x2 y square plus x square y dash into dx assumes extreme values. It assumes extreme values on the straight line, on the straight line y equal to x. Let's discuss the next question. We need to show this functional x1 to x2 y square plus x square y dash into dx assumes the extreme values on the straight line. So let's take f of x comma y dash as, what shall we take f of x comma y dash as? Y square plus x square y dash. So this is our f of x comma y dash. Next let's apply the Euler's equation. Dou f by dou y minus d by dx of dou f by dou y dash, that is equal to 0. This is our equation. What it will become? What is dou f by dou y? It is 2y. What is dou f by dou y dash? It is 2x square, not 2x square. It is only x square y double dash. Am I correct? No. Differentiation of y dash will be 1. What? Yes. Differentiation of x square into y dash. With respect to y dash, when you differentiate, y dash will be 1. So you will have only x square over here. So let's substitute in the Euler's equation. What do we get? Dou f by dou y is 2y minus d by dx of dou f by dou y dash is x square. That is equal to 0. So differentiate it again. What do we get? 2y minus d by dx of x square. What is the differentiation of x square? It is 2x. That is equal to 0. So on dividing by 2 and rearranging, what do we get? Y equal to x. So this is what we need to prove. Correct? What is it asked? We need to show that this functional assumes the extreme values on the straight line y equal to x. So in order to check that, y equal to x. So we can say that this functional attains its extreme values on the straight line y equal to x. It's a simple question. Anybody has any doubt? Anyone any doubt in this?
No, ma'am.
No, ma'am.
Okay, let's discuss one more question. Find the extremal of the functional. Find the extremal of the functional I is equal to integral 0 to pi by 2 y square minus y dash square minus 2y sin x into dx. Y square minus y dash square minus 2y sin x into dx under the conditions y of 0 equal to y of pi by 2 equal to 0. So there are two conditions. So functional is given. Let's take f of x comma y dash as y square minus y dash square minus 2y sin x. So this is the function. Okay, write down and solve along with me, everybody. Okay, so let's apply Euler's equation for this. What's Euler equation? Dou f by dou y minus d by dx of dou f by dou y dash equal to 0. Okay, correct? Yes? Is it okay, everyone? Okay, let's find dou f. Let's find dou f by dou y. What is dou f by dou y? It is 2y. Then here this will be 0. What about this term? Differentiation of y will be 1. So we will have what? 2 sin x minus 2 sin x. Is it okay? So this is dou f by dou y. What is dou f by dou y dash? What is dou f by dou y dash? Dou f by dou y dash will be minus 2y dash. Let's substitute in the Euler's equation. Dou f by dou y is 2y minus 2 sin x minus d by dx of dou f by dou y dash is minus 2y dash. Correct? That is equal to 0. So simplify this. What do we get? 2y minus 2 sin x, this minus and this minus will become plus, d by dx of 2y dash will be 2y double dash equal to 0. So when we divide by 2 and we rearrange the terms, what happens when we rearrange the terms? We will have y double dash plus y equal to sin x. Okay, this sin x I have taken to the other side. 2y dash plus 2y equal to 2 sin x. The two term you cancel out, so we will get y double dash plus y equal to sin x. So now we have a second order non-homogeneous differential equation. Second order non-homogeneous differential equation. So how to solve this second order non-homogeneous differential equation? We have to replace this one. So in the previous term it was not d into d minus 1. We have to replace it by d. Y dash has to be replaced by d. So it is two terms, so it will become d square. Similarly over here also, if you have the term y double dash, you have to replace by d square. d square plus 1 into y. D square plus 1 into y, that is equal to sin x. You have to replace y double dash by d. Y dash by d, so d square will be y double dash. So when you simplify this, you get d square plus 1 into y equal to sin x. This is the second order differential equation. First find the complementary function. How do you find the complementary function? By taking the homogeneous part, that is d square plus 1 into y equal to 0. This is a homogeneous part. So we have the homogeneous part, d square plus 1 into y equal to 0. Let's find the auxiliary equation. What is the auxiliary equation? M square plus 1 equal to 0. Is it okay, everyone?
Yes, ma'am.
Are you able to hear me?
Yes, ma'am.
Yes, ma'am.
Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay. M square plus 1 equal to 0. So what will be the value of m? If m square plus 1
Minus.
equal to 0, so what will be the value of m? Plus or minus I. M square equal to minus 1, m will be plus or minus I. So m will be plus or minus I. So when you have the imaginary roots, how complementary function is given by, if you have a plus ib as a root, a plus or minus ib, it will be e power ax into c1 cos bx plus c2 sin bx. This is how you write the solution if you have complementary roots. If you have complementary roots, you are going to write it that way. So what will be yc? Yc will be, here a will be 0, so it will be e power 0x, e power 0x into c1 cos x plus c2 sin x. c1 cos x plus c2 sin x. So this is the complementary function. What is the particular integral yp equal to? It is the term on the right hand side, that is sin x divided by d square plus 1. Sin x divided by d square plus 1. When you have yp as sin x by d square plus 1, there is one more. First we have learned if you have e power ax by f of d, what to do. Now we have sin ax or cos ax by d square plus 1. In that case, what we had to do? We had to replace these d square by minus a square. If you have sin ax by whatever, sin or cos by d square plus 1 or d square plus a or any term, you have to replace this d by minus a square. So here it is sin x, so a is what? 1. So what you have to do? You have to replace d square by minus 1 square. Minus 1 plus the denominator becomes equal to 0. So when the denominator becomes equal to 0, what we have to do? We have to multiply by the variable x into sin x, then differentiation of the denominator. Differentiation of d square plus 1 is 2d. So here we will have, this is nothing but, remember everybody, this is x by 2 into 1 by d stands for integration. So it is integration of sin x. So what do we get? What is integration of sin x? It is integration of sin x is minus cos x. So you get x cos x divided by 2 as the particular integral. So what is our final answer? Y equal to yc plus yp, where yc is c1 cos x plus c2 sin x minus x cos x divided by 2. So this is our function. But now we have two initial conditions. What are the initial conditions? Y of 0 equal to 0. So when I put y of 0 equal to 0, that means the cos 0 will be 1, sin 0 will be 0, and this entire term will be 0. So we will get C1 as 0. Next, when you put y of pi by 2 equal to 0, that is when x equal to pi by 2, y value is 0. So here y will be 0, 0 is equal to cos pi by 2 will be 0, so C1 into 0 plus C into sin pi by 2 value will be 1. Correct? Sin pi by 2 value will be 0. And cos pi by 2 will be again 0, so you will have 0. This is nothing but C2 value is also 0. So C1, C2 both are 0. When you substitute that, we get y equal to C1 is 0, C2 is 0, so we get x cos x divided by 2. So this is the required extremal. Anybody has any doubt in this? Anybody has any doubt in finding the extremal using the Euler's equation? Anybody has any doubt?
No, ma'am.
Okay. So what we have discussed in today's class, we have discussed making use of the Euler's equation, how to find the extremal of the functionals. And Euler's equation is given by dou f by dou y minus d by dx of dou f by dou y dash, that is equal to 0. So making use of this Euler's equation, we are finding the extremals of the given functional. Let's meet in the next class. If you have any doubt, please contact me. Thank you everyone.